Hello, everyone. Good morning, good afternoon, and welcome to today's healthcare webinar, Turning Complexity into Strategic Advantage for Healthcare Facilities. My name is Jennifer Heath. I lead the product marketing team for OpenBlue Digital Solutions here at Johnson Controls. Thank you so much for joining us. I'm going to give you a quick intro to the platform we're using today for our webinar. Over on the right-hand side, you'll see options for chat and Q&A. The chat is a public chat, so you can submit questions, comments, interact with other attendees here today. You can also submit questions directly through the Q&A, and those will come directly into the OpenBlue team, and we will take those after the webinar. We certainly invite you to introduce yourself in the chat. We always love to know who's out there, where you're joining us from, what your functional role is in your organization. So if you feel so inclined, please feel free to introduce yourself there. And with that, I am going to turn it over to our team for introductions, and I hope everyone enjoys today's presentation. Thank you.
Thanks, Jen. I'm Janice House, and I'm the Industry Executive Director for Healthcare and Life Sciences at JCI. What that really means is we work on end-to-end solutions, and we make sure we understand the industry's trends and challenges, and we make sure we have the products, the services, and the solutions that meet the end customer's needs. I'll turn it over to Kyle.
Hi, everyone. Kyle Shamrock here, Executive Director of Product Management for OpenBlue Industry Solutions and Connected Services. On the industry solution side, I focus specifically where the intersection of the building and the mission of the industry, healthcare being one of my main focuses. Charlie?
Thank you. I'm Charlie Gans. I'm our global portfolio leader for healthy buildings and sustainability. And what I get to do at Johnson Controls is work across our various groups, across digital controls, equipment, and really start looking at the overall life cycle of how those products fit within a building and how we put better solutions together for our customers. Back to you, Jen.
Thanks. We really thank you for joining us today. What you do is essential. Obviously, healthcare is a huge market for us and for you. And I'm going to state the obvious. What you do each and every day to keep the facilities up and running 24/7 and focusing on patient care is amazingly hard. So we're going to ask you how you do that and what the complexity is that you most look at. So what's driving that complexity in your environment, in your facility? We're going to have a polling question. It's going to come up on the screen, and we want you to select, multiple selection here, the things that are really driving that complexity for you. Keep going. Okay. Wow. Amazing, right? What's driving the operational complexity and challenges in your facility? Critical environments like ORs, ICUs. Wow, 71%. Labor shortages, that was really key over COVID. Alarm fatigue, 13%, disparate systems, a lot of data, no good insights. Wow. Okay, let's turn it over to Charlie and talk about regulatory compliance, talk about how difficult those regulatory issues are. Let's go back one page. Overviewing those really big challenges, let me just take a step back and really look at what we see in the industry. No surprise to you, the operational pressures and the need to reduce cost. We do have aging buildings and they need a lot of servicing. So that is one thing that we see, not necessarily what came out in the polling issue. The environmental impact of the healthcare facilities, aging service and workforce, increased demand of personal care, and the shift from large hospitals to the ambulatory care centers, and changing and evolving regulatory compliance. So that's what you said, 71% of you said we want to talk about today. There are also stricter privacy and regulation demand, increasing security. We may want to talk about that next time we get together. And then the increased adoption of technology and digitization. So again, let's go back to changing and evolving regulatory compliance and what's happening. So Charlie?
Great. Thank you so much, Janice. And yeah, when we're talking about these critical environments, and it was really interesting, some of the feedback that came back around the compliance side of it, like it kind of boils down to really, at least for our discussions today, is around, performance and compliance, energy consumption, and then resilience of these systems and how they're operating. So when we talk about the performance itself, like what those, what those areas are, what we need, the parameters basically that we have to have these spaces operating within, we're talking about ASHRAE 170. That's talking about the ventilation within these spaces, what the relative humidity is, how many air changes we need, what kind of pressure relationship we need to have within those different spaces. So that's really our go-to when we're looking in that space. One of the big things with healthcare, and I'm sure you're all aware of that, but I mean, healthcare itself, hospitals are typically 3 times more energy intensive than like a commercial space or other types of buildings. So already we have very high energy use intensity rates. But then on top of that, if we look at some of these critical spaces like an OR, they're typically another 3 to 6 times higher in that energy use intensity within the health hospital itself. So we really want to focus on those, on what the energy consumption is within those spaces, because that's typically our lower hanging fruit when we're looking to scale back our energy costs. And that's what we see there on that middle standard that we have there, which is ASHRAE 90.1. And this is the last rendition is 2022. But what they recently did, and when I say recently, literally last month, is they added this addendum BH. And what that addendum is saying that, although ASHRAE 170 has said, let's have setbacks for unoccupied times within ORs and other types of spaces. Now 90.1 has adopted that and actually has put in some more tighter language around that and saying that you shall, now start to scale back have those setbacks within those spaces. And it has some other caveats around, okay, you can designate a certain amount of those spaces as 24/7, continuously operating. You can have, resets within there so that you can go back into an operational mode, different types of things like that. But they're very specific that these areas need to be set back. And we know the reason behind that is that because they consume so much energy. Then if we go into the one on the right there, that's a relatively new guideline as well. So that's an ASHRAE guideline 43. That's really pointing back at 170 and saying, well, okay, how do we have to operate our hospitals so that we can achieve 170? And not just achieve it, but have that resiliency built into it, and that we're going to have that continuous operation. And that really expands upon not just the rooms themselves, but into the equipment that's supporting those rooms. What do we need to do for the air handling units to make sure that they're maintained and they're not going to have, they're not going to have an issue or a fault? What are we doing with the chillers and things like that? Because as you start looking at, of course, in the space, there's some resiliency that we need. But as we expand beyond those spaces, if we were to lose an air handling unit, that air handling unit might be supporting multiple ORs. We can't have something like that happen. So I really encourage you to take a look at that guideline if you haven't seen it before, because it's got some really important information around how to mitigate those risks and also what to do if they have an excursion. What happens if you lose that relative humidity within that space? And it actually goes on, it's time-based. So it looks at certain different times and says, well, if it's happened within an hour, you need to do this. So it's a really helpful guideline. And again, it's through ASHRAE and ASHE, and it's very much drawn from ASHRAE 170. So with that, so now we've got kind of our underlying principles here, looking at that energy, looking at the compliance, looking at the performance. This is a kind of an artist rendition of a OR suite. So when we look at this and we start looking at how much data is available that we're looking at, we go throughout everything that we could possibly look at for that compliance standpoint. When we're talking about whether it's Joint Commission or some authority having jurisdiction. But how do we utilize that data? How do we control it? How do we make sure we're within those thresholds that ASHRAE 170 is requiring? So if we start in the upper left there and we look at that sensor It shows 72 degrees on it. That's temperature and humidity. So, that calls out certain thresholds within 170 for those that we'd have to maintain. And the reason for that isn't like typically you think of those conditions as something for comfort, but it kind of goes beyond that for an OR, because if we're outside those thresholds, we start getting into situations where we could have, microbial growth. We could have, bacteria, mold, things like that, because we're outside of that humidity and or that temperature. Another side of that for humidity is that, we obviously within these spaces, we don't want any type of condensation. So that's a real critical part of this, and that's something that we report into our for compliance. As we start working our way around clockwise, you'll see those two metal cylinders with the red circles around them. So what those are, if you're not familiar with them, are air valves. So similar to what a VAV box may do, these are really regulating the supply as well as the exhaust within that space. So these are very critical parts of this critical environment. So on the supply side, when we go back to 170, we're looking at basically 20 air changes per hour going into that space. And then if we look at the exhaust side, we want to be able to pull that exhaust back, but we don't want to pull back the full 20 air changes per hour, because we're also using these valves not just for airflow, but also for pressure control. And within an OR, we want to maintain, it's not a very big pressure differential, but we want to make sure that when those doors open on the right, that the air is gently being pushed out versus anything that's going out outside of that space is being drawn back in. So we really are looking at keeping that sterile environment within those spaces. So that's what we're doing with the pressure control. Back to the airflow, what we're looking at when we talk about those 20 air changes per hour, it's kind of an interesting kind of concept there, because instead of talking about CFM, cubic feet per minute that we talk about a lot with airflow, we're talking about air changes. So when we talk about that, we're really talking about that volume of space that we're talking about, the entire space within that operating room. So if we have a 600 square foot space, 10-foot ceilings, that's basically 6,000 cubic feet that we're looking at. Well, if we, we're thinking, okay, well, we're going to be moving 20 times that every hour. And it's a lot. It's a lot of air that we're moving within that space, but it's a little bit, I won't say misleading, but it can be a little bit misleading for someone who's not as familiar with these spaces, in that in your mind, you think of an air change, you're thinking, okay, I'm taking that entire space of air and taking it from the supply and flushing it out to those exhaust sides. That may or may not be the case, and that's really why we need to start looking at, when we think about these spaces, we need to start thinking about ventilation effectiveness. So if we look at the ceiling above, like where the operating table is, that's our supply. What we're attempting to achieve there is have a sterile environment of air that's flowing down towards the patient, around the staff. I think the 170 requirements are like a 12-inch perimeter all around that table itself. So we're putting that sterile shroud of air that's going to the patient, keeping that air clean, keeping it within that temperature and relative humidity guidelines that we're looking for. And then ideally what we want to have happen is that air is then going to go capture all those contaminants or anything that's dangerous within that space, and then efficiently flush it out to those vents that we see on the walls, on the far wall to the right and to the left, and exhaust that out of that space. And that's what we mean by ventilation effectiveness, because what we find in a lot of these spaces is that we're trying to, we're concerned about not meeting with compliance. So we're, what we say, quote unquote, overperforming. And what that means is we're going over those 20 air changes per hour. And that may be helpful, but it also can be harmful, because if we're going too high, what happens is those velocities are too high. They're now going down along the floor. They could be, picking up contaminants that may be along that space. They may be pulling in like little circulation or eddy zones that may have contaminants or pathogens, swirling within them. We may have a case where we have circulation around the door itself when those doors open up. So we want to be very careful about overachieving, not just from an energy standpoint, but also from an effectiveness standpoint. And then talking about real quickly about the air horsepower, or the energy that we're consuming within that space. Well, this is very heavily conditioned air, and many hospitals are running these rooms 24/7 because they're concerned about that resilient side of it. If they scale it down or if they turn off that area, how are they going to get back up into those conditions? And that's something that now that's what 90.1 is addressing, saying that, well, if you're not using that space, you really need to scale that back. And that could be a little bit challenging in itself as well, because we want to make sure that we're not getting to a condition where air can now come in from that hallway back into the space. We want to still make sure that we're achieving that temperature, humidity, and pressure differential, but we also want to make sure that we're scaling back the airflow itself so we're not consuming as much energy. So as we're working around there, so that's really what we're talking about when we're trying to get in those spaces. And then, finally, just touching back on that guideline 43, resilience and OR cannot go down. I mean, that is really the situation that we have here. So we need to make sure that all the equipment that's supporting that OR, all of the mechanical equipment, is in the right running condition, so we're not taking that risk on and having those problems. So just to kind of wrap up, all that data is being captured. It's just 1 second there. Just all that data is being captured. It's being brought into the BMS or into the BAS. Great for facility people, but maybe a little bit of a challenge for anybody outside of facilities people. Look at that. And with that, Janice, what you want to?
Yeah, great explanation. Everything inside the room really clear. It's challenging. How do you take all that information out, and how do you measure it? How do you indicate it? So Kyle, talk to us a little bit about how do you measure it? How do you indicate what's going on outside the room, and if it gets out of condition?
Yeah. So hi, everyone. And thank you, Janice, and thank you, Charlie. So, what we see and what I want to kind of talk to you about is how do we take the complexity that we see here and turn it into a strategic advantage, right? So, and we can do this on two fronts, one on the energy side and on the compliance side. So I've spoken to many hospitals about how they're managing and maintaining their operating rooms. And let's talk on the energy side first. A lot of them will say, listen, we know the operating room is consuming a lot of energy. We know why. We know it's because of these ASHRAE 170 standards running to these high airflow, high HVAC requirements. And we know we can set it back, but we don't, because the capabilities that are available to me in my HVAC control system just don't account for the complexity that exists within an operating room. As Charlie mentioned, when you need the operating room for surgery, whether it's a planned surgery in the middle of the day or an emergency surgery in the middle of the night, or maybe just a surgery that goes over, how do you account for all that and make sure that the operating room is in the right parameters if you are taking a setback strategy? And so what I found is hospitals went two routes. Most of them, like 95% of them, just left them 24/7, 365 at those high energy standards. The others looked for some sort of setback strategy, but they took a very complex, self-developed or manual approach to managing it. So think of it like someone sitting at a desk and watching the surgery schedule and changing the schedule in the BMS to accomplish that using manual forms, or they're going and they're self-developing. What we think is a better approach is utilizing building technology and integrations to deliver a automated solution that's robust enough and deals with the complexity. And that requires a couple different components. First, it requires OT integration. And specifically what we're talking about is surgery schedule integration. What's awesome about today's surgery schedules and the EMR systems is they are integrated systems. So now your clinicians, your OR managers, your nurses, your surgeons, they're all incentivized to keeping that information up to date. And you can use that now through the available integrations that exist with like an Epic or Cerner. These things are built to facilitate integrations to other systems. You can actually take that information and build it into how you're managing your operating rooms so that you're managing it to the surgery schedule. But as that surgery schedule changes, your BMS is changing along with it and delivering setbacks and delivering that energy savings along with that. Additionally, you want to think about and utilize IoT integration. And so what we're talking about specifically here is on occupancy sensors, and we're talking about creating visibility. Because one of the challenges you have, I talked about how great surgery schedules are now that they're becoming integrated. but they may be updated, maybe a little bit late. They may not be 100% accurate. You want that redundancy with an IoT's capability, like a like an occupancy sensor that's detecting that occupancy and bringing that into the decision-making algorithm. So not only using the surgery schedule, but also occupancy sensors, as well as giving the visibility and the capability for the clinicians to see and override the system if they want to. And then the last piece of that then is creating that visibility. So bringing that data to the cloud so that anyone can see at any point in time, what is the condition of the operating room? Is it functioning correctly? Is it in the right parameters? And like I said, giving that override capability. So what we're finding is that old paradigm of like, hey, we're just relying on our BMS system to deliver an energy saving setback strategy no longer exists. You have the ability through this IoT integration and through occupancy sensors and surgery schedule integration to create a more robust decision-making process for how you control, as well as creating that visibility to all those stakeholders, which then that visibility gets into the next piece on the compliance side. So one of the things that we also see is on the compliance side is all of this data about the status of the operating room. Are the air changes correct? Is the humidity correct? Is the pressure correct? All that information is available in the BMS system. And what we find so many times is it's clinicians who are in there conducting the surgeries, but they don't have visibility to this data. And so what we're finding is just a really simple solution is utilizing different type of HMI solutions, human interface machine type solutions, like a screen either just outside the operating room or at the nurse's station that will show them, hey, here's the status of your operating room. Is it in the correct, are you in the correct parameters? Are you trying to conduct a surgery? Are your air changes correct? Is your humidity correct? All these things, are they correct? And if not, you can even, give them simple solutions. Like if you're using a setback, you can put overrides into these HMI solutions so that they can go just push a button and override any sort of setback on their own. You can also provide capabilities so that if something's out of compliance and it needs to be dealt with, clinicians, you want to inform them, hey, is the room ready for surgery? And if not, what do they go do, right? Because they're not going to be knowledgeable enough about what to go do. That's typically going to reside with facilities, but you want them to be aware. So you can give them messages like, hey, your operating room is out of compliance. You're trying to conduct a surgery, but you're out of compliance. Here's what you go do. You can put that directly onto these HMI machines so that they get that really simple messaging and can take action. And all that is how now you're starting to take the complexity of how an operating room is run and how it's dealt with today, and not just leaving it in its current status like, hey, we're going to leave it as is and hope that everything's okay. We can use the available data and systems to provide a different and more robust strategies to setting back the operating room, which gives you the energy savings, which, by the way, I didn't comment on, is somewhere in the neighborhood of like $5,000 to $7,000 per operating room per year, as well as giving that visibility to your clinicians. And then additionally, you can take it even a step further on the compliance reporting piece of it, right? So this is all kind of like real time. How are we ensuring that the operating room is in the right conditions when we're going to conduct a surgery? You can also now start to log that data with different cloud-based reporting solutions or other reporting solutions and track that in history so that you can show, hey, as you were conducting surgeries, we were in the right parameters and we're tracking all these metrics. That's one of the main things we see with Joint Commission is not only do they want to see, hey, are you in the right parameters, but do you have the right processes in place? And these types of things, these types of integrations and these capabilities help demonstrate that process that you need to have to ensure compliance. So that's how we see it going today and how we see it evolving. I don't know, Janice, if you want to kind of summarize for us.
Outstanding. I think you just did. I don't see any questions in the chat. Please put them in the chat and we will address them here or we'll address them afterwards. But clearly, Charlie addressed a lot of the new standards, a lot of the information you do need to track. You do need to track it for compliance, JCI, and Kyle showed you a way of visual management, easier tracking and compliance. The autonomous control enables obviously operational efficiency, energy reduction. It also integrates technology that unlocks that operational value. It helps staff really focus on patient care while the buildings help focus on the things they need to. Digital and AI-driven solutions do create that strategic advantage. One of the things that we believe we can talk about next time, and the industry wants us to talk about, is the stages of autonomous buildings. And you see here, we've gone from legacy spaces, building standalone systems, to connected spaces. We all have connectivity between that single dashboard in a building. We pretty much all have those control rooms, and those control rooms usually have a central control room. 2 or more systems manually integrated. Many of you have many more systems manually integrated, but we do have those controls that help you integrate. And now we have smart spaces. They're intelligent, they're coordinated, the workflows help do that. We have AI built into the controllers. And now what you just heard from Kyle is the digital overlay. We have had over the last quarter, no less than 10 symposiums, digital symposium with Microsoft, et cetera. So we're all talking about generative AI. It's been in existence for 5, 10, 15 years, but now agents are now able to talk to agents, and agents are now able to themselves do certain things. And that's called autonomous spaces. We'd love to have a seminar on this, but we also want to ask you what's most important to you. So we have a last polling question, and that polling question will come up in a second. And we want to know what you want to talk about next time. Okay, maybe we can use the chat. And the topics we have is transition from, we got it. Thank you, guys. Transition from smart to autonomous buildings, 50%. Wow, this is great. Energy optimization for cost savings and emission reduction. Clear 50 and 50. Perfect. We will take both of those back, and we will format 2 webinars to address both of those topics. And no one had another topic to address. Absolutely very important to all of us. So we want to thank you for participating today. Again, we really appreciate the opportunity to dialogue with you. Next time, we hope there are some more questions, and we will speak to you soon.